Right, how did you get on with the extra work that was sent? Any problems with those questions?
I did 5, 7, and 9. I don't know if those were the ones you told me to do, but I
Yeah.
did them.
How did you find those?
Not too bad.
Not too bad. Okay, good. All right, so just as a warm up then, shall we start off with these two and see how you get on with these two, yeah?
Okay.
Okay. While you're doing that, I'll just pop my phone on charge.
For the first one, I got bracket 2x minus 5 and bracket 2x plus 5.
2x minus 5, brackets 2x plus 5.
Yep.
Okay, now worth checking that one. Worth checking this one. So what did you do as your first step?
Times 4 and 25.
Well done. And that gave you what number
100.
Good. So when you times these two, we've got 100. Good. What next?
And then see what times this to 100 and adds to minus 20.
Okay, and what were those things that you found?
Minus 10 and minus 10.
Thank you. So the two of them you found, you said, from this 100 were a minus 10 and another minus 10. Okay. And what did you do from there then?
And then I did 4x squared minus 10. Then
Minus 10x.
yeah, and then minus 10x plus 25.
Okay, good. And then we have our little border, don't we?
Yep.
Okay. Then we factorize each side. What do you get when you factorize this side?
2x brackets 2x minus 5.
Okay, good. So you get 2x brackets 2x minus 5. Then what should we do as the next step?
Then put the 2x minus 5 on the outside.
On the other side?
And then you add the 5 to factorize it.
So what number should I put here?
5.
You
No,
sure?
minus 5.
Thank
Minus
you.
5.
Good. What's next now? I group everything together, don't I?
Yeah.
That groups with this. And these two form one bracket. So what does that give me then?
2x minus 5 and 2x minus 5.
Good. And 2x minus 5. Perfect. Square. So this can be rewritten as 2x minus 5 squared. And that's your answer. You happy with that?
Yeah.
What did you go wrong?
I actually forgot the minus on the 5, so.
Okay, no problem. Okay, just something worth checking. Okay, good. What about the next one then?
I got x equals square root of 30 plus 5.
X equals square root of 30 plus 5.
And or x equals minus square root of 30 plus 5.
Plus 5. Okay. Of course, this can be simplified, the square root of 30. But let's just check your method. So what did you do then? You divided this by 2 first?
Yeah.
Yeah. So you wrote x minus 5 squared. Is that what you did? And then what did you do on this side then? What did you have after this x minus 5 squared?
Minus 25.
Minus 25. Good. Which is equal to 5. Okay, absolutely spot on. You took this to the other side, which made that 30. And you have x minus 5 squared. So in other words, I can take out the square and take the square root, and it's obviously going to be plus minus. So you're absolutely spot on. But I can simplify this a little bit better if they wanted it in simplified form. What can root 30 be simplified to in terms of surds?
Root 10 and root 3.
Root 10 and root 3. Yeah. Root 3, root 10 plus 5. Or x is equal to minus root 3 root 10 plus 5. Yep. Okay, yep. Good stuff. Very good. Now, the next part of quadratics is not as demanding as what you have been doing because it involves using the quadratic formula. So it's probably not something we're going to dwell on for so long because you have used that quadratic formula at GCSE. Can you remember what form the quadratic formula takes?
Nope.
Okay, so it says that x is equal to minus b plus minus b squared minus 4ac over 2a. Remember that formula?
Yeah.
So if I gave you a problem, and let's just look here and see, because you probably can see my screen. By using the formula. So if we had something like this here, e.g., 11x squared plus 2x minus 7 is equal to 0. How do you use that formula to work out the answer to this?
Would you substitute the values for the
Okay,
letters?
okay, so have a go at it and see what you get. So you know which letters are which. So what letter does the 11 represent?
A.
Well done. What's your B?
2.
2, good. And what's your C?
Minus 7.
Minus 7, good. The whole of it with its sign is taken. So that is the C, okay? And of course, the same applies here. We're also looking at the sign. Again, here there's a positive sign, so we're also taking the sign. Very important to remember that, okay? It's not just a number. So what do you get when you plug that into your equation then?
Minus 2 plus minus 2 squared.
2 squared.
Minus 4 times 11 times minus 7.
Okay.
Divided by 22.
Divided by 22. Correct. Okay. So what does this all simplify to?
Wouldn't I need the calculator to?
Okay, yeah, I would advise that you definitely have your calculator handy for this kind of stuff. Do you have a calculator close by?
No.
Okay. Do you have a calculator on your phone?
Yep, I'll use that.
Okay. So just a reminder, let me call.
Should I round to 1 decimal place or?
I'd prefer you leave your answer in thirds at this stage, just for good third practice.
The answer on the calculator is in thirds, so I don't know.
You can still use your calculator to work this out. Add it to 4. Yeah. And then you can use thirds to simplify it. If you need a helping hand there, what are we saying? It's minus 4 times 11 is minus 44. Minus 44 times 7, what's that? 44 times 7 gets 308. And then you add 4, because this is a positive term now. Add 4 plus 4, and you get, we need to find the square root of 312 plus minus 2 over 22. Okay, so what does that simplify to? This simplifies to minus 2 plus minus root 4 and root 78. If I multiply 78 times 4, I get this thing here, yeah? Over 22. Minus 2, well, that's 2. So this could be minus 2 plus minus 2 root 78 over 22. Can I simplify this a little bit further now?
Divide by 2.
Divide everything by 2. You're right, I can take a 2 out. So if I take a 2 out, I remain with minus 1 plus minus root 78 over 22. Divide by 2 there, and I have 11 at the bottom. So my final answer is minus 1 plus minus root 78 over 11. So it's either x is minus 1 plus root 78 or minus 1 minus root 78, in each case divided by 11. So far, so good?
Yeah.
Okay, great stuff. So we're going to do some exploration on this quadratic formula because it can be pretty useful, especially this thing inside it, this b squared minus 4ac. Okay, we've got a name for that part, that b squared minus 4ac. Any ideas what that is called? This part of it, b squared minus 4ac. So I'm only focusing on that part there. Any idea what that's called?
No.
Okay, so we call that the discriminant. Now, in other words, this discriminates, it allows us to know the characteristics of our quadratic equation down to even what it would look like if we had to sketch that function. So it's a pretty useful thing, and you will be tested throughout your A-level course to ensure that you understand the usefulness of b squared minus 4ac. It will crop up very often, matter of fact. So best you keep this in your mind, keep it in your memory bank, because they will not tell you about it, so to speak, to say use b squared minus 4ac. So always remember that that is what we refer to as the discriminant. Now, hopefully you can, if we start looking at this and looking at this b squared minus 4ac, firstly, let's ask ourselves, because we're taking a square root of this b squared minus 4ac, we take the square root of the discriminant. What would happen if b squared minus 4ac, let's look at a few examples. What would happen if b squared minus 4ac was greater than 0? What would happen if b squared minus 4ac was greater than 0? Would I be able to find the square root of it?
Yeah.
Correct. And how many values of x is it going to give me?
2.
2, because there's going to be a plus and a minus of that square root that is greater than 0. You're right. So what this means, if b squared minus 4ac is greater than 0, it tells you that you have what we call real roots. In other words, in relation to a quadratic function, if I have my x-axis and my y-axis like that, what this is telling me is that it will look okay, thank you. It will look something like this. It's going to cut at 2 distinct places.
Yeah.
Okay. Also, if this a is positive, okay, that a, if that's a positive number, it means that your quadratic will have a smiley shape. So this is for positive a, in other words, a greater than 0. However, if the a is less than 0 and it's negative, it's going to have what they call a sad face. A less than 0, where a is negative. So if this was minus 11x squared, for example, then the graph would look something like that. But because it's plus an a, or it's greater than 0, the a, it will look something like this. And if the discriminant here, the b squared minus 4ac, is greater than 0, it means that this curve will cut the x-axis at 2 distinct points. And these are what we mean by the roots. It's where the curve cuts the x-axis. Okay? This value here, on the other hand, where it cuts the y-axis, we call that the y-intercept. Now, at the y-intercept, let's just ask ourselves, what is the value of the x-coordinate at the y-intercept?
0.
0, well done. So to find the y-intercept, all you simply do is put 0 as x in this equation. So if we had to put x as 0 in this equation, what value would I come up to? Minus 7. Because all that would disappear, which means that if I had to sketch this graph, it would cut the y-intercept at minus 7. Are you happy?
Yeah.
Okay. To find these roots, let's ask ourselves, What is the coordinate of the y value at these points where it cuts the x-axis?
0.
Well done. To work that out, we make our y 0. That is why when we're solving this quadratic, we put a 0 at the end, because that would tell us where it cut the y-axis. Are you following that pattern so far? Because
Yep.
really, the way a quadratic expression is expressed is this. So by making y 0, I'm finding out where does it cut the x-axis. By making x 0, I'm finding out where does it cut the y-axis. Okay, so just a little quick note. Y equals to 0 allows us to find the roots. And if this is equal to 0, gives y-intercept. Okay, so you do one thing at a time first. First, you make y 0, solve the equation. It'll give you where it's cut the x-axis. And then find the intercept. You make x 0. And then, of course, by looking at whether this is positive, you can then decide whether it's a smiley face, like so, or a sad face in the case of it being negative. So far, so good. Okay, good. So we're still going to carry on then, looking at these properties of the so-called discriminant. So I'll take this off. Now, what about the event where b squared minus 4ac is equal to 0? In other words, if this is equal to 0, I can take this b squared, this minus 4ac to the other side of the equation, to the right-hand side, and this gives me b squared equals to 4ac. So let's imagine now that the value of b squared here was the same as 4ac. What happens to what's in this now? What happens to the discriminant?
Cancels out.
It doesn't quite cancel out. So now this is 4ac take away 4ac, because the b squared is equal to 4ac. Or you can think about it as this 4ac is now b squared. So I've got two b squares, b squared minus b squared. What happens in there?
0.
0. What is the square root of 0?
0.
You're right. So now hopefully you can see that instead of having plus minus, because plus minus of 0 doesn't mean anything, I'm only going to end up with a solution where x equals to minus b over 2a. Can you see that? That is if this b squared minus 4ac has the value of 0, which is what I've said. If b squared minus 4ac is equal to 0, let's imagine that's 0 there. Square root of 0 is 0. That disappears. Plus minus 0 no longer means anything. So I only have one value of x. Can you see that? Good. Now this here is what we call, we have a name for that, and we call these repeated roots. Repeated roots. So in the case of the first question, which was 4x squared minus 10x, what is it, plus 25, I think?
Yeah.
You look at this problem here now. You'll probably realize, if by looking at it, that try and find, what's the value of the discriminant? Give me the value of b squared minus 4ac for this thing here. What does that give you? B squared minus 4ac. Find the discriminant of this equation here. What do you notice? Find the value of the discriminant. So identify your b, your a, and your c, and then use this formula for the discriminant to find its value.
Okay. Minus 100.
You sure?
Yeah.
Can't be minus 100 because you can't find the square root of minus 100.
Oh, sorry. Square root of 200.
Okay, let's try and find, this is our A, that's our B, that's our C. The formula is B squared minus 4AC. Yeah. So what's my B squared? It's minus 10 squared. I'm using this formula here, by the way, so stay with me, yeah? Minus 4. What's the value of A? It's 4, yeah? What's the value of C? It's 25. So what do you get here then? 4 squared, is that the right expression we used? This was the expression we used, isn't it?
Yeah.
So what does this give us then? So I get 100 here, B squared minus 4 AC. And what do I get over here? It's not a good example I've used here. 400, is that right?
Yeah.
What did we get? We got an answer of 2x minus 5 squared, didn't we?
Yep.
Okay. All right. I'll probably just scrape this example because it's not a very good one. I'm just wondering why. So b squared minus 10 squared, 100 minus 4ac, which is 25. So 100 minus 400, we're getting minus 300. Not a good example, but I'll go back to trying to explain what I mean anyway by repeated roots. Okay. So if we come over here, in that expression, you'd found 2x minus 5 squared, isn't it?
Yep.
Equals to 0. So what are the values of x that would give, there's only going to be one value of x. So you can say 2x, yeah, minus 5 equals to 0. So 2x equals to 5. So you get x equals 5 over 2. If you were solving that equation I gave you, are you happy with that?
Yep.
Because there are two brackets of 2x minus 5, you would get 2x minus 5, x equals 5 over 2, or x equals 5 over 2. The same thing again in both cases, because you've got two brackets here, which are the same. So this one gives you x equals 5 over 2. That one also gives you x equals 5 over 2. You agree with that?
Yep.
So in this case, we call these repeated roots. You happy with that, yeah? So we
Yep.
call them repeated roots. So what that means is that for a graph with repeated roots, if the A is positive, it's going to be a smiley face. But what that means is that it's only going to skim or touch the graph in one area, 1 point. And this here is what we call a repeated root. So in other words, there'll only be one solution where x touches the x-axis, or where the curve touches the x-axis. Another final situation which we're going to look at is this one, b squared minus 4ac, when it's less than 0. Well, when b squared minus 4ac is less than 0, I'm going to have a look at the other one, by the way, just to make sure we've troubleshot it. When b squared minus 4ac is less than 0, it means that this number is negative. Can you find the square root of a negative number?
Yeah.
Can you? Try and find the square root of negative 5 on your calculator. So do we have any two numbers that can multiply together and give you a negative result? That's the other question I'm asking.
No. No.
Or do we have the square root of a negative number?
No.
No, there's no square root of a negative number. What that means, if your b squared minus 4ac is less than 0, it means that you have no real roots. In other words, we say that the roots are complex, and you'll learn about complex numbers later on, probably if you do decide to do further maths and things like that. What this means is that the shape of your graph, firstly, whether it's a smiley or a sad face will depend on whether the A is positive or not. If the A is positive, what that means is that your graph does not cut the x-axis and it will look like this. Does not cut the x-axis. If A was negative or A was less than 0, then it would look like that. In either case, it would not touch the x-axis. So this here, just to remind you, this is if a is less than 0, and this is for a greater than 0. So far, so good?
Yep.
Okay, great stuff. Okay, so we're going to have a look at a few questions here. Yeah, I'll pick a question from the textbook. I'll minimize this and hopefully you'll be able to see my screen. Okay. Now, Sope, hopefully you can see my screen and the questions. Can you?
Yep.
I can make it a little bit bigger. Well, for number 1, happy for me to take this off? Any questions?
I'll keep it there just in case I need it.
Okay, cool. I'm going to put some space there, but I'll take this top part off so we can use that. Okay. So it says, sketch the graph of the following equations. Now, it's just a sketch. So what's going to be important is we want to show the salient points. What I mean is we want to show where it cuts the x-axis and where it cuts the y-axis or the y-intercept, okay? So first thing we noticed, we've got to be thinking of this form. Yeah. Now, is my A positive or negative?
Positive.
Positive. So I know the graph is going to look something like this. Yeah. Now, let me work out what the discriminant is. B squared minus 4AC. I'm trying to find out, does this cross the x-axis? If I use my B squared minus 4AC, my B is 3 squared 9 minus 4. My A is 1. My C is 2. So I get 9 minus 8, and I get 1. I get a positive value. So because my discriminant is greater than 0, which is here, I know I have real roots. So I know it's going to cut at 2 places, okay? So if I want to find those 2 places where it cuts, what do I need to do? I need to make my y equals to 0. You happy?
Mm-hmm.
So if I make my y equals to 0, this is going to give me where it cuts the x-axis. Factorize this, and what do I get? I get something like x plus 1 and x plus 2, don't I?
Yes.
Yeah. So now I know that this cuts at x equals minus 1 or x equals minus 2. So if I therefore sketch my graph, the other thing I could do is also try and find out, well, what is the y-intercept? Where does it cut the y-axis? Well, I only simply need to make x 0 to find out where it cuts the y-axis. And what value does that give me?
Pardon?
Where does it cut the y-axis? So how do I find out where this equation cuts the y-axis? What do I need to do? Can you remember what I said? If you want to find out where a curve cuts the y-axis, ask yourself, what is the coordinate at the point where a curve cuts the y-axis? What is the coordinate of x?
0.
0. So what should we do with that value of x? We know that where it cuts the y-axis, x is 0. So what should I do to work out where this cuts the y-axis?
Substitute x with 0.
Very good. And what value does that give me?
2 only. Y equals 2.
Y equals 2, good. So I know that the y-intercept, it cuts the x at y equals 2, okay? So now I can have a quick feel for what this looks like. That's my y equals 2, and I've got my minus 1, and I've also got my minus 2 somewhere here, okay? So if I had to draw this graph, it looks something like this. Cuts there, and then it passes through that value. Of course, I haven't drawn it the best way, but you want it to look, you want it as much to be like that. So I could even change this slightly to make it look a bit neater and more realistic as a parabola. Okay, so there we go. And this here will be minus 1, and that there will be minus 2. And that is your sketch done. Okay. And that's all that is required of you. Are you happy with that?
Yes.
All right. So have a go at, all these are positive. Have a go at B. Have a sketch of B then. Sketch the graph of B.
The discriminant for this will be minus 31, right?
Minus 31. Are we sure about that? Let's just look at it then. So you've got your B is -3, and your A is 1, your C is 10. So B squared is 9, minus 4 times A is 1 times C, which is 10. Yeah. So 9 minus 40, what did you get?
Minus 31.
So you got root of minus 31.
Yeah.
So you know that your discriminant is less than 0. So what does that mean? It means that your graph is going to be
No real root.
no real roots. You're absolutely right. You're not going to have any real roots for that one. But we can work out where it cuts the y-axis. What does it cut the y-axis?
Um. How do I do that again?
Okay. To work out where it cuts the y-axis, at the point where it cuts the y-axis, the logic we're using is, what is the value of the x-coordinate? Remember, anytime you're given an expression, it is giving you the relationship between the x-coordinate and the y-coordinate. That is what an equation is. It's the relationship between the x-coordinate and the y-coordinate. So where it cuts the y-axis, you know that the value of x is 0. So you can put that value of x as 0. It will give you the relationship that x has at that point with y. Okay?
Y equals 10.
So you get y equals 10. So what should your sketch look like now? Does your sketch look like this? No, it's going to cut at 10 somewhere. Yeah.
Yeah.
And what shape will it assume? Will it be a smiley face? Will it be a sad face?
Sad face.
Sad face, why would it be a sad face? Remember, sad face only happens if A is less than 0.
It will be a smiley face.
A smiley face, absolutely. So what will it most likely, what shape will it take then? Smiley face, as you've said. So it could be something that goes this way, or it could be something that goes this way. And what could you do to find out where it goes? You could use the completing the square method to find out whether it's lying this side or this side. Okay? All right, let's have a go at number 2. How do you reckon you might go about number 2?
I have no idea.
Okay. By the way, repeated roots almost also means equal roots. So here, you give an x squared plus kx plus 4 is equal to 0. Find the values of k for which this has equal roots. If it has got equal roots, it means that b squared minus 4ac must be equal to 0. In other words, it means that b squared is equal to 4ac. So you need to know these properties. When b squared minus 4ac is greater than 0, it's got real roots. When b squared minus 4ac is equal to 0, or when b squared is equal to 4ac, we say it's got repeated roots. If b squared minus 4ac is less than 0, it means there are no real roots. So you've got to memorize these three sentences here. Okay? So we want equal roots. Okay, so what's my a in this case? I'm going to be using this formula, and I know that I want equal roots, so I've got to make that equal to 0. So what's A? 1. What's B?
Okay.
Okay, good. What's C?
4.
4, good. And I put them into this equation. So this equation now becomes my B is K, so I get K squared minus 4. My A is 1, my C is 4, and this is equal to 0. Happy? Now here I get K squared minus 16 is equal to 0. Now all I've got to do, take that to the other side, I get K squared equals 16. Therefore, K is equal to plus minus the square root of 16, which is plus minus 4. So K can either be, so K is equal to 4, or K is equal to minus 4. If you use any of these values and put a 4 there, or a minus 4, and then you try and solve that, that is going to have equal roots. You happy with that? Okay, have I got number 3?
Would it be K squared equals minus 16?
K squared equals minus 16. That doesn't sound right, because you can't find the square root of a negative number, so it can't be right.
Yeah. Well, when I put it into the discriminant, I got 8 squared minus 4 K
Minus
squared.
4. Okay, shall I take this off so we look at it together?
Okay.
Yeah, just take this off here. So you've got kx squared plus 8x plus k is equal to 0. So what are the values of a? What's A? K. What's B?
8.
What's C?
Okay.
K, cool. Now, you know, this is our guy, and that's obviously going to be 0 because it's for equal or repeated roots. It's the same terminology. So b squared is 64 minus 4 times a, which is k, times c, which is k. And you get equals to 0. So I get 64 minus 4k squared equals to 0. This minus goes there, and now I have 64 equals 4k squared.
Oh, I actually put the 64 to the other side and made it a minus. So
yeah, it doesn't matter. Even if you did that, that's going to be minus 4k squared equals to minus 64. So you've got two minuses on each side. So they cross out.
Okay.
Yeah. Divide by 4. Divide by 4. That gives me k squared equals to, what is 64 divided by 4?
16.
16. And now all I've got to do is find the square root. So k is plus or minus 4. Take the square root of that. Okay, good. So what we're going to do next then is, Sam, we're going to have a look at some exam questions, shall we? So you start building your knowledge on what kind of stuff you would face in an exam regarding these. So these are previous exam questions. Let's have a look and see which ones. 10 marks. Shall we have a go at might as well start from the top here. Start building our exam technique. Number 1.
Okay.
I'll make this bigger so you can see it. By the way, Sope, I realized where, sorry to cut you short here. I realized where we went wrong when we did, it's just a quick one here, just for completeness sake. This was 4x squared minus 20x plus 25. That was the first question I gave you in the warm-up. And if you do b squared minus 4ac of this, because this had repeated roots, it does work, because I think I put it minus 10, that's why it didn't work. So you can see that your a is what, your b is minus 20, so 20 squared minus, so it's b squared minus 4ac, 4. My a is 4, and my c is what, 25. 25 times 400, 100 times 4 is 400, 20 squared is 400, so 400 minus 400 equals to 0. So the discriminant of this is also equal to 0. That's why you had repeated roots. So I made an error when I said minus 10, okay? So that was just as a quick one to correct that, so it doesn't confuse you. So the method does work. It's not just, it's not like it only works in some other instances, it works all the time. Where are we? Oops, sorry, we're at this one. I'll bring this here. There we go.
X plus 3 squared minus 11.
X plus 3 squared. Yeah. Plus what again, sorry?
11.
Plus 11.
Or minus.
Take your time. You've done these. Simply think about it. Somebody's just asking you to write this as in using completing the square. So you're not even solving anything. So what did you get again? X plus 3 squared plus 11.
Minus 11.
Minus 11. Right, okay. So let's have a look at this together then. And I'm going to bring my... Oops. If it can move. Oh, come on. There we go. Now you can see it side by side. So what's the technique we use? We got x squared plus 6x plus 11. So what do? We divide this part by 2. Yeah, middle part. So I write x plus 3 squared. Now when I expand x plus 3 squared, what do I get? Remember, this is my original equation here, Sope. So
Yeah.
when I expand x plus 3 squared, what do I get? I get x squared plus 6x plus 9.
Yeah.
Yeah. Now, how different is this equation here to that one? What's the difference between those two equations?
It's minus 2.
Minus 2. In other words, what do I need to add or subtract to this equation, to this expression here, so that it
2.
becomes equal to? I need to add a 2. So that means that all I simply need to do is add a 2 on the outside of that. Okay? So try and practice those because you don't want to throw away. They're nice, easy marks. It's 2 marks, and they know that you've been doing it since GCSE, so they're not going to give a lot of marks for that. Okay? So just be methodical and do practice in the week between sessions because obviously I only just see you once a week, and if you're not practicing in between, it's going to be a bit of a struggle to keep up with everything. Okay, in the space at the top of page 7, sketch the curve with equation y equals to x squared plus 6x plus 11, showing clearly any intersections with the coordinate axis. So you've got 2 marks. Says show clearly any coordinates with the intersections with the coordinate axis. So remember, this is our final answer. So what might that look like? What would your sketch look like? So here, oops, x plus 3 squared.
Do we have to use the discriminant or?
The discriminant is a useful thing. You could definitely use the discriminant, yeah, but there's no point because it says find the value of the discriminant of x squared plus 6x plus 11 at the later part. But it would be a good thing in terms of just knowing, because it says clearly, showing clearly any intersections with the coordinate axis. Now we've got to ask ourselves, oops, you've just written that expression, and this is equal to y. That's the relationship between the x and the y. So if I want to work out where it cuts the x-axis, firstly, what is the value of y at the points where it cuts the x-axis?
0.
0. So I could put a 0 there, couldn't I? To work out where it cuts the x-axis. So I get x plus 3 squared plus 2 equals 0. Solve that equation, I get x plus 3 squared equals minus 2. What problem have I encountered there now? Can you see the problem?
Yeah.
What is the problem?
You can't find the square root of a negative.
Very good. So there's a problem there. So I know clearly that this does not cut the x-axis. That's the first thing I note. It does not cut the x-axis. But I can use this expression now and start thinking in a little bit more detail as to what's happening. So at the point where x is minus 3, yeah? At the point where x is minus 3, what does this expression reduce to? Well, if I put minus 3 there, minus 3 plus 3 gives me 0. I get y as 2. So I get a certain coordinate which says that actually I've got something, so sorry, when x is minus 3, that goes to 0, that makes y 2. So I know I can write that this is a coordinate set, minus 3, 2. Are you happy with that? By putting minus 3. In other words, I ask myself, what value of x should I put here to make this 0? So I have to put x as minus 3. And what value of y does that give me as a result? Well, that gives me a y value of 2. That's why I've written this minus 3, 2. Now, this is pretty important because when I sketch my graph, I know that at the point minus 3, 2, minus 3, 2, that actually represents the place where I'm going to have a minimum for my graph. So when I sketch this graph, it's going to look like this. And it doesn't touch. Remember, it doesn't touch or cut the x-axis. And I can work out that value of where it cuts the y-axis. What value will that be?
Oh, 2. I mean, or 3.
Have another think again. Where it cuts the y-axis, and I'm now using the cursor to give you a hint, what's the value of x?
6.
No, where it cuts the y-axis. What's the value of the x coordinate here?
Oh, 0.
0, good. So what am I going to do with that?
Substitute.
Good. And what's that going to give me?
11.
11. So that should be 11. So did you see how I used this expression from the completing the square? I looked for the value of x that would make this 0 and found the corresponding y coordinate. And that point, minus 3, 2, represents the minimum for this particular graph. So this graph is, remember what we said, we know that the A is positive, so it's going to be a smiley shape. If the A was negative, it would have been the other way. So this here we call a minimum. That's the minimum point. So to find the minimum point, remember what we said, you find the value of x that will make this bracket equals to 0. Happy? And then work out or see what the y value would be. So when this is minus 3 plus 3, 0, 0 squared is 0, meaning that y equals to 2. That's why I said when x is minus 3, y is 2. And that's the point I then represented here. So far, so good. Okay, next one, find the value of the discriminant. What is the value of the discriminant for that expression?
Minus 8.
Minus 8, yeah. And it's a negative, which is what we'd expect. Because if it's negative, remember what we said, if you've got a negative discriminant, so a discriminant is less than 0, you've got no real roots. This thing will be hovering. Yeah? Okay, great stuff. Right, now, just try to check. I'm not sure if this paper actually does have a mark scheme, so you can obviously look at the answers yourself when you're going through them. Does it? Yes, it does. Great. So there you go. That's your minus 8 that you found. Okay. And there you go. That's the shape. Okay. And you've also, well, they haven't put that point, but you've identified, we went as far as identifying what that point is. We said that's 3, 2, no problems. Okay. and that was it being factorized. Okay, right. So, Sope, we have definitely come to the end of our session at the moment, but there is a lot of practice in here. Now, my suggestion to you is try and work through as many problems. In fact, at A level, I always encourage you to bring me questions, not the other way around. I shouldn't be bringing you so many questions. Get into the habit of finding questions, challenging yourself, and bring them to the session as well. But in the meantime, you've got a nice, decent bag of questions here to give you ample practice. Try and do as many as you can. I'm not expecting you to do all of them. If you do all of them, hey, the better. You can only get absolutely good if you do all of them. But if you don't, that's not a problem. But if you do struggle with any of them, do bring them forward into the next session. How does that sound?
Good.
Okay, and listen back to the video in case some things probably you didn't quite pick them up that well. So you've got another chance to just refine your knowledge or refine your confidence as well. Great stuff. So I'll see you next week, and thank you for having accommodated an early start today. All right. Nice one. See you soon, Sope. Have a good one.
Bye.
All right. Cheers. Bye.